So we're going to look at a different way of solving for quadratic equations called completing the square. So we've already talked about factoring. If you can factor the left side, if you have something ax squared plus bx plus c, if you can factor both sides, or the left side, you can set each part equal to 0 and solve each part. We also talked about the square root property. If you don't have that bx part, you can solve for x squared and then take the square root of each side. So this next method kind of combines those two. It has parts of the factoring and the square root property in it. So this is how we're going to do it. So our example, we're going to do x squared minus 8x plus 3 equals 0. And I want to solve this. Solve for x. Solve for x. Now looking at this, I'm not going to be able to factor it, because if I have a, if I try to do it, it's going to be a 3 and a 1. There's no way I'm going to get the outer and inner to be a minus 8x. Okay, so that's not going to work. So I need to think about what could I have. I'm going to skip a line here. What could I try to factor that would get me that minus 8x in the middle, that bx term? So I'm going to ignore the 3 now. Actually, what I'm going to do is I'm going to bring the 3 over to the other side. So I have x squared minus 8x. I'm going to put something, leave a little space, I'm going to put something there, equals negative 3. So I have to look at that. X squared minus 8x plus what is going to work so that my outer and my inner add up to a minus 8. Now it's always going to be the same thing, because you'll see in a minute we're going to use the square root property. So if I think about what's one way to get minus 8, well, a minus 4 and a minus 4 would work, because then my outer would be minus 4x, inner minus 4x. Now, so if I set it up like this, my last would be a minus 4 times minus 4 is a plus 16. Now, so and I'm doing that kind of randomly, but as long as if I'm adding 16 to the left side, as long as I add it to the right side, I'm not changing the equation. It's still a legitimate equation. So now negative 3 plus 16 is 13. Okay, so now this x minus 4 times x minus 4. Well, we know that that's the same as x minus 4 squared. And now you can see that we can use the square root property. So if I take the square root of both sides, on the left that cancels out that squared. Now I just have x minus 4 equals, now remember here when we have the square root property, plus or minus. Two possibilities here, positive or negative square root of 13. And now I just have to do one more step to get the 4 to the other side. So I have a 4 plus or minus the square root of 13, and that is my answer. Okay, so I mean I could go back and plug that in, check it. Maybe if you did want to do that, I would do the decimal approximation. Remember, this is two answers: 8 plus square root of 13. Sorry, 4 plus square root of 13, and 4 minus square root of 13. You could get the decimal approximations, plug it in that way. Probably be the easiest way to check it. Okay, so that one wasn't too bad, because it was kind of easy to see, okay, this is a minus 8, minus 4 to get the minus 8. That becomes a plus 16. But notice this is always going to be the case. To figure out what this number is, I'm going to add this in right here. And then I'll use this in the next example. If you take your b divided by 2 and then square it, that is what we are always going to put in that spot, plus whatever that is. Okay, so in this case it was 8 divided by 2 is 4 squared is 16. Because that's always going to, help fit in this, what should go in that factored part. Okay, now let's do another example, because in that last one, the leading coefficient was 1. So now, if the leading coefficient is not 1, the leading coefficient is not 1, we first have to divide each side by the leading coefficient. Because then, if I divide each side by the leading coefficient, then I will have just an x squared, not a coefficient in front of x squared. Okay, so let's say, this one's going to be a little trickier. 2x squared minus 2x plus 7 equals 0. Okay, so first step, I have to get that to be just x squared, 1x squared. So divide both sides by 2. So that means I have x squared minus x plus 7 halves equals 0. Okay, so now just like the last one, I'm looking at this, there's no way I'm going to be able to factor to get something to multiply to 7 halves and add up to a minus 1 in this case. I'll put a 1 there. So I'm going to move the 7 halves over, get that out of the way. So I have x squared minus 1x, leave some space, equals a negative 7 halves. So now I have to look and think about, well, how am I going to get my numbers to multiply to some number and add up to a minus 1? And now remember I said you could do b divided by 2 squared. So in this case, b is a minus 1. Doesn't really matter if it's plus or minus because it's always going to be plus what we plug in right there. So if I take 1 divided by 2, that's a half. And I square it, that's a quarter. Because, do 1 divided by 2, a half. If I put a minus 1 half, minus 1 half, my outer would be minus 1 half x, inner minus 1 half x, minus a half is a minus 1. And then my last, multiply minus a half times minus a half, it becomes a plus 1/4. So what I did is I added 1/4 to the left side. So now I have to add 1/4 to the right side. And it looks like I'm going to need a common denominator here. Double the top and bottom, get 14/4 plus 1/4. Okay, so I've got x minus 1/2 squared equals negative 13/4. Now I can do my square root. X minus 1/2 equals plus or minus. Okay, so here, this I could do something. First of all, there's a negative in the square root. So what does a negative in the square root mean? I. Square root of 13, I'm not going to be able to do anything there, but the square root of 4 is 2. So I'm going to rewrite this like that. So I square root of 13 divided by 2. So I can do the square root of 4 is 2. Okay, so now I have to add a half to both sides. X equals. Now I have a common denominator, so on top I have 1 plus or minus I square root of 13, and then that's divided by 2. Since common denominator, just put the whole thing over 2. And that is my answer. It looks a little funny, but that is my answer. Now this one, you could check it. It's going to be pretty hard to plug it back in because you're going to have an I, but it's doable. But that is kind of how we're going to leave our answers, especially with that I there. We're not, obviously going to get one number. If we did want to split it up to be written like a complex number, 1/2 plus or minus I root 13 over 2 is another way I could write that. But you typically would just leave it as the one big fraction form, which you'll see in the next way to solve these that we're going to do.